Children, in last class we have discussed about potential energy of a dipole in an external field, and there we got the relation U equal to minus P dot E. Now, before discussion, let us recap the chapter 1 where we discussed about conductor and insulator. Conductors contain mobile charge carrier. In metals, mobile charge carriers are electrons, and the valence electrons are free to move. These free electrons randomly move in different direction, but in external field, they drift against the direction of field. While positive ions made up of the nuclei and the bound electrons remain held there in their fixed position. In electrolytic conductor, charge carriers are both positive and negative ions. But the situation where we have to deal the movement of charge carriers. In chapter 3, we will came to know the chemical force also responsible for the movement of charge carriers. But right now we will discuss the solid conductors and electrostatics of solid conductors. In this, we will discuss behaviors of conductors in electrostatic field, dielectrics and polarization. First, different properties, behavior of conductors in electrostatic field. From this part, every year one question as the short question, very short answer question. First property, net electric field intensity in the interior of a conductor is zero. If we consider a conductor that may be neutral or may be charged are placed in electric field, then due to presence of field, the negatively charged electrons will move against the direction of field, leaving cloud of positive ions. As a result, an electric field is induced, and we know the direction of field is from positive to negative. The alignment of electrons in such a way that the induced electric field is equal to the external field. So E net inside the conductor is zero. Next property, electric field just outside the charged conductor is perpendicular to the surface of conductor. Let us here a charge Q, and due to this charge Q, electric field E, area vector is along this direction, And here we are taking E is not perpendicular to the surface, means not in the direction of the area vector. Then this E can be resolved as E cos theta. Due to E cos theta, the surface electron will not remain at rest, and we are dealing electrostatic, means charges remain at rest. So this is not possible. Next property, net charge in the interior of a conductor is zero. Let us see. If we use the Gauss law, which says surface integral E dot ds is equal to q by epsilon naught. But the property one say electric field inside the conductor is zero. So if we use in this equation E equal to 0 means q by epsilon naught equal to 0, so q equal to 0. Next property, charges always resides on the surface of a conductor. Let's some excess charge are given, then see it is distributed. Reason, inside charge can't go because inside, as we have just seen, the third property, net charge in the interior of a conductor is zero. So all the charges have to reside on the surface of a conductor. Electric potential is constant for entire conductor. Remember the relation between field and potential, that is E equal to minus dV by dr. So E equal to 0 inside, so dV equal to 0, so V equal to constant. Also we have learned this charge distribution, continuous charge distribution. There we came to know about the surface charge distribution, that is charge per unit surface. Let us say surface like this, charge is given. Here the surface charge distribution will not be same, because see this side surface area is more, so surface charge density will be minimum. This side surface area is less, so here charge density is maximum. And on the basis of this, before 2 years there was in the syllabus, that is Van de Graaff generator, that is corona discharge, sharp point having the more surface charge density due to less surface area. Just see, sigma equal to q by s. So if s is more, sigma will less. Now electrostatic shielding. The field inside cavity is always zero. Whatever the size or shape of the cavity, or whatever we charge on the conductor, may be placed the conductor in some external field, but inside cavity field is always zero. Now some general or important properties we can see here. Inside the cavity, electric field is zero, but potential is constant. Here, inside E is zero, so this sigma is also rho is zero, that is volume charge density. Here this positive charge is induced, then electric field is outward. Inside and surface potential is same, but electric field inside zero, but on the surface there will be electric field. Now dielectric and polarization. Dielectrics are non-conducting substances. Conductors we know which conducts, but net electrostatic field in the conductor is zero due to free movement of charge carriers. Dielectrics, free movement of charge carriers not possible. So the charges polarize, and in external field a dipole moment induces, and that induced dipole moment results opposing field. The very important term, that is polarization. Dipole moment per unit volume is polarization. For linear isotropic dielectrics, what is linear isotropic dielectrics? That is, in which induced dipole moment is proportional to the field and is in the direction of field. For linear isotropic dielectrics, polarization is proportional to electric field. So here proportionality constant, that is called electric susceptibility, and its unit will be, see, dipole moment per unit volume. Coulomb meter is the unit of dipole moment, volume meter cube. So Coulomb per meter cube. If we see here the conductor and dielectric, see, in presence of electric field, the charge carriers are separated, and in such a way, as much as electron will move opposite to the field, the same amount of positive charge. Absence of negative charge is equivalent to positive charge. So external field is equal to induced field. Magnitude equal, direction opposite. So E net is 0. But in dielectric, the situation is not like that. So net electric field is not 0. Now, before moving forward, though earlier we have also discussed the polar molecules and non-polar molecules. So once again recap. The polar molecules in which the center of positive and negative charges do not coincide with each other, means they have a permanent dipole moment. Say in the case it is the water, the direction of dipole moment P. Example, water, carbon dioxide, alcohol, etc. Now when the polar molecules are placed in electric field, first, in absence of field, The alignment we can see, not in some specific direction. So that is the random and net dipole moment is zero. But in presence of field, see the orientation. Now the dipole moments are aligned. So we can say now the induced dipole moment. Now the non-polar molecule. The molecule in which center of positive and negative charges coincide. Now its effect in absence of electric field. So in absence of, since centers coincides, so no dipole. But in presence of field, see a kind of stretching. Means electrons pulled opposite to the field. So a net dipole is formed. Now come to once again dielectrics. Polarization of dielectrics. When a non-polar dielectric slab is subjected to an electric field, dipoles are induced due to separation of effective positive and negative centers. In absence of electric field, see the non-polar dielectrics. Now, if it is placed in electric field, E naught, now see the alignment. So, an electric field is induced. It means net electric field is E naught minus EP. The dielectrics reduced the field. Now the dielectric constant, which is E naught by E naught minus EP, means applied by net electric field. Now polarization vector, though polarization we have seen earlier, same is the polarization vector. Dielectric strength. Dielectric strength is the maximum value of electric field intensity that can be applied to the dielectric without its electric breakdown. For air, breakdown field is 3 into 10 to the power 6 volt per meter. And the unit of dielectric strength is volt per meter. Practical unit is kilovolt per mm. Now, some dielectric strength of some dielectric medium is given. Next, we will discuss capacitors and capacitance. From that part, 3 marks and 5 marks question generally are being asked. Thank you.